A rapid colorimetric method to estimate reducing and non-reducing sugars in fruits and vegetable samples. Dr. V. Parao, Dr. Sanjay Singh, Dr. A.K. Singh and Dr. D.S. Misra. An attempt was done to estimate reducing and non-reducing sugars by different procedures, and a method was developed to estimate sugars in easy, cheap, fast and accurate manner. This was estimation of blue color of Fehling's solution at 730 nanometers in a fixed volume. The intensity of blue color is inversely proportional to the amount of sugar reduced. Based on the intensity of blue color, the sugar was estimated by preparing standard curve. Principle: the reducing sugar when heated with copper sulfate solution in Fehling's A and sodium potassium tartarate in Fehling's B, the copper is reduced from the cupric to cuprous state and thus cuprous oxide is formed. The leftover reagent which was unreacted maintain blue color, which is measured at 730 nanometers and according to sugar is estimated. Materials and methods. Reagents. 1. Fehling's A, 69.28 grams of pure AR-grade copper sulfate crystals are dissolved in distilled water and made to 1 liter. 2. Fehling's B, 346 grams of pure sodium potassium tartarate, Rochelle salt, and 100 grams of pure sodium hydroxide are dissolved in water and made up to 1 liter. 3. 0.5% glucose solution. 5 grams of glucose is dissolved in distilled water and volume is made to 1 liter. Procedure. A method to estimate reducing sugars in fruit and vegetable samples colorimetrically by using Fehling's solution was developed in our laboratory. For this test 5 ml of Fehling's A and 5 ml of Fehling's B solution were added in a 250 ml glass beaker, and a fruit sample containing less than 50 mg reducing sugar was added. The sample was heated for 3 minutes, and after the solution changes its color the sample was diluted and volume was made to 25 ml. After settling of the precipitate, the transparent unreacted Fehling's solution was estimated colorimetrically at 730 nanometers wavelength. For this method a standard curve was prepared by using 0.5% glucose solution. 0, 12.5, 25, 37.5. 50 mg of glucose was added through 0.5% glucose solution by adding 0, 2.5, 5, 7.5, 10 ml of that solution. For each test a standard amount of 10 ml Fehling's solution, 5 ml Fehling's A plus 5 ml of Fehling's B, was added, and the standards were heated for 3 minutes so that complete reduction of glucose was taken place. Then the standards were cooled and diluted to a common volume of 25 ml and allowed for complete settlement of the red precipitate. After settlement of the precipitate, the clear transparent unreacted Fehling's solution was fed in the spectrophotometer at 730 nanometers and corresponding absorbance was recorded. For samples also the same procedure was followed by using specific common volume for all samples for comparison and actual quantitative estimation of reducing sugars by using standard curve developed in this procedure. For this method care should be taken that the sugar in the sample should not exceed 50 mg. So a rough estimation of sugars by using refractometer was done so that sample may not contain more than 50 mg sugar. For example, the final extract should contain a range of 0% to 8%, and according to that concentration and the volume of solution to be taken varies from 10 ml to 0.5 ml respectively. In order to avoid confusion in taking the volume and concentration of sample solution, a concentration of 2 to 4% and 1 ml of that sample solution was kept optimum. However, the below information was given for convenient estimation of sugars. For sugar concentration: 0 to 0.5% range 8 ml of sample solution. 0.5% to 1% range 4 ml of sample solution. 1% to 2% range 2 ml of sample solution. 2% to 4% range 1 milliliter of sample solution. 4% to 8% range half a milliliter of sample solution are ideal for this colorimetric test.